Welcome to Brain Vision.
Let's find an equation of the tangent plane to the surface z equals x sine of x plus y at the given point. So let's recall the formula for the tangent plane, where the surface is given by f. So here we're just adopting the same convention as the book, where z is f of xy, unless stated otherwise. So using this, the equation of the plane, of the tangent plane, and here what I mean by x naught, y naught, and z naught, it's in general the point at which the plane is tangent to the surface. So in this case, these values are given, -1, 1, and 0. Then we multiply that by x minus x naught. And similarly, for the partial derivative with respect to y, multiply by y minus y naught. So we can see based on the formula, we'll need those partial derivatives. So let's go ahead and evaluate those. Differentiate with respect to x. We see x appears in both factors, so we'll go ahead and use the product rule. And then from this, you can go ahead and plug in x naught and y naught. These are given. So we'll have sine of 0 minus 1 and then cosine of 0. So sine of 0 is 0, cosine of 0 is 1, so we have a -1 there. So also we'll need the partial derivative with respect to y. This time x is constant, so we could just differentiate the sine part. And then from this, we see that fy -1, 1 is again -1. So now let's plug in all this information into the formula for the plane. So we have z minus 0, so that's just z. Fx, that was -1, the partial derivative. And then x minus -1. Plus, and then now we're on to y. So this is -1. And then y minus 1. So this becomes z equals, so we'll have a minus x. We'll also have a minus y. And then let's watch out for these negative signs. So we have a negative, positive, -1. And then over here, we'll have a negative, but then another negative. That's a +1. So simplifying that gives you z equals -x minus y. And we can stop right here. But if you like, you could also rewrite this as x plus y plus z equals 0. But either one of these is fine. And that's our final answer.